Welcome to Module 5 of the Works Clearinghouse, WWC, Group Design Standards Training. You can access all of the resources mentioned in this module through the WWC's website, whatworks.ed.gov. This module focuses on the second step in the process of reviewing findings from group design studies, namely, determining how units were assigned to the intervention and comparison conditions. In this module, we will recap the different types of group designs that are eligible for WWC review. We then will explain how the WWC determines the integrity of random assignment in randomized controlled trial designs. And finally, we will describe how the WWC determines whether assignment to conditions was done at the individual level or the cluster level. The second step in the group design study review process entails assessing assignment to conditions. Studies that have no confounding factors and that have at least one outcome aligned with the WWC's standards will advance to this step in the review process. At this step, reviewers examine the process that study authors used to determine assignment of units to the intervention and comparison conditions. It is during this step that WWC reviewers will examine how assignment or allocation to conditions was carried out and whether any factors may have compromised random assignment if present. Notably, assignment to conditions is a critical component of a research study's design, as it affects the WWC's confidence in claims that the intervention caused the observed effect. This then affects the study's WWC research rating, which we discuss later in this module. Let us begin by discussing the considerations around assignment to conditions in randomized controlled trials. Recall that randomized controlled trials, or RCTs, are those where units are randomly assigned to two or more conditions. In a simple RCT, one group receives the intervention and the other serves as a comparison group. The units assigned to conditions might be individuals, such as teachers or students, or they might be clusters or groups of individuals, such as classes or schools. Researchers may use different methods to conduct random assignment, which may include, for example, blocked random assignment, matched pair random assignment, random subsampling, re-randomization methods, or using predetermined probabilities to assign units to conditions. Because well-executed randomization, on average, creates groups that are similar on observable and unobservable characteristics, the WWC has the greatest confidence in effects from well-executed RCTs. In other words, well-executed randomization provides assurances that any observed differences in outcomes for the intervention and comparison groups are because of the intervention and not because of any pre-existing differences between groups. For this reason, well-executed RCTs are eligible for the highest research rating of meets WWC standards without reservations. In order to determine whether random assignment was used in a study, the WWC tends to accept authors' claims about random assignment. However, the WWC will still look for anything that suggests the study did not conduct well-executed random assignment. When the description of the assignment process is incomplete in the study, the WWC may contact the authors with questions. The WWC carefully reviews the entire text for a study, paying attention to how the authors describe the process and not just to the labels the authors use. For instance, sometimes authors only say, students were randomly assigned. But later in the study, they may say they included a student in the analytic sample who was not actually randomly assigned to a condition, which would be a sign that randomization may not have been well executed. Whatever the case, the authors do need to say that they randomly assigned units to conditions. Otherwise, the WWC assumes assignment was not random. Finally, the WWC is not concerned about who actually executed the random assignment, as long as there is no reason to believe that the study used a compromised randomization process. For example, some studies take advantage of a pre-existing lottery, such as those often used for charter school admissions, and the researcher had nothing to do with that random assignment process. The WWC would still consider this a randomized assignment process. Some studies may conduct a well-executed random assignment process, but something happens later that compromises it. Let's discuss a few acceptable RCT designs. In one acceptable design, units, such as students or teachers, volunteer to participate. Then, the study randomly assigns those who volunteer to the two conditions. Volunteering might seem like a concern because there may be something different about people that causes them to volunteer. But if the study randomly assigns volunteers, whatever characteristics cause them to volunteer will be present and at about the same levels in both groups. The design essentially controls for those characteristics. Another fairly common acceptable randomized design uses stratified random assignment or blocking. Researchers may identify particular characteristics that they want to make sure are present in both groups. For example, the study may stratify on gender, meaning that a group of students is first separated into two, one for boys and one for girls. Then, random assignment occurs within each of these two groups or strata. Researchers might use this strategy when they want to make sure that the intervention and comparison groups have similar ratios of boys and girls. In that case, the researchers would block the students by gender and randomly assign them separately within the gender blocks. Study authors can block on just about any characteristic. They may also choose to block on multiple characteristics. For instance, if the researchers want to make sure to have high, middle, and low achieving students in both conditions, they could block by achievement level and randomly assign students within those blocks. Of course, randomization doesn't always go smoothly. So the WWC always assesses whether randomization was well executed using two criteria. First, the study must assign units entirely by chance. For example, a study might use a random process like a series of coin flips to do this. When units are assigned to groups based on a series of coin flips, belonging to the intervention group is unlikely to be related to other characteristics of the units, such as students' prior test scores or their race or ethnicity. Other random assignment processes include those based on lotteries and random numbers generated by computers. However, some approaches to creating groups that might seem random may not actually be fully random. For example, a study might assign units who have birthdays from January to June to the intervention group, and those with birthdays from July to December to the comparison group. The WWC does not consider this to be well-executed random assignment. This is because research indicates that people with the same birthday may share similar characteristics. This is true for adults, but is especially true for young children. For example, using month of birth to create groups in a kindergarten class might result in an intervention group with students who are relatively older than the students in the comparison group. The intervention students might perform better on the outcome because they are older, and not just because they received the intervention. Again, the WWC would not consider this random assignment because assignment must occur entirely by chance. We also sometimes see studies that use class schedules to assign students to conditions. But relying on class schedules also does not count as random assignment. Think about when you were in high school. If you were a member of the band, then you likely had most of the band members in your classes throughout the day because that was the only way to make your schedules work. The problem with class schedules is that students with certain characteristics often take the same classes, so the groups are not truly random. The second criterion for whether randomization was well executed is that every unit in the analysis must have a chance of being assigned to each group. So if a study randomizes students to 3 conditions, then every student must have the opportunity to be assigned to each group. In other words, a non-zero probability of assignment to each condition. For instance, if the study authors can say that Anita had the opportunity to be assigned to any of the 3 conditions in a study, but DeAndre only had the opportunity to be in 2 of the conditions, then this would not be well-executed randomization. If a researcher chooses to assign someone in the analytic sample to a particular condition, the WWC cannot review that study as a randomized controlled trial. This issue arises when researchers randomly assign some, but not all students to conditions. For example, researchers may work with principals or teachers to assign a particular student to a group based on that student's needs. If the study is testing a behavioral intervention and one student has significant behavior challenges, the researchers might purposefully assign the student to the intervention group. Typically, researchers exclude these purposefully assigned units from the analysis. If so, then the study can be reviewed as an RCT. But if the study includes the student in the analytic sample, then the WWC cannot review it as an RCT because the randomization process has been compromised. Recall that in many eligible RCTs, study authors may use stratified or block random assignment of units to conditions. Researchers also may use designs in which probabilities for the randomization process vary across strata or blocks. For example, let's imagine that researchers are using a randomized design with two strata, one group of schools that are making adequate yearly progress, or AYP, and another group of schools that are not making AYP. For schools that are making AYP, the researchers used a 50-50 ratio for assignment, meaning that they assigned schools using the equivalent of a fair coin toss. Then for schools that were not making AYP, let's say the researchers used a 70-30 ratio for assignment, meaning that these schools were more likely to be assigned to the intervention group. The schools that are not making AYP were more likely to end up in the intervention group because there was a 70% chance that the study would assign them to that group. This is acceptable for the WWC. Studies do not have to use a 50-50 split for random assignment, and the probabilities of assignment can differ across study units, as long as each unit had a chance of being assigned to either condition. However, in scenarios like this, where researchers use different probabilities for randomization, the WWC does require the study authors to account for the different probabilities in their analysis for the randomization to be considered well executed. We will next discuss the options for doing this. If a study uses different probabilities for randomization, it must account for those different probabilities in the analysis to preserve the integrity of the random assignment. If the study does not account for the different probabilities in an acceptable manner, the WWC considers the randomization compromised, meaning it was not well executed. The WWC requires the analysis to account for the different assignment probabilities because the intervention and comparison groups can end up looking very different from each other if the study uses different probabilities to assign units to the groups. For example, in the scenario on the previous slide, only 42% of the intervention group schools were making AYP, but in the comparison group, 63% of the schools were making AYP. These groups are not similar, but accounting for the difference in the analysis can address this issue. Studies can account for different probabilities in one of three ways. First, they can use inverse probability weights by applying weighting methods to rebalance the intervention and comparison groups. Second, they could use an indicator variable, also called a dummy variable, in the analysis for each sample. In our AYP example, the researchers could use this method by including an indicator for AYP status. This basically signals in the analysis which schools are making AYP and which are not making AYP. Under the third approach, studies can estimate effects separately and combine them later. In the AYP example, the researchers could produce two impact estimates, one for the schools that were making AYP and one for the schools that were not making AYP. Then, they would average those to produce a single impact estimate. Using any of these three approaches would maintain the integrity of a randomization process with different probabilities. Researchers also may choose to use a re-randomization method for group assignment. Recall that in our discussion of randomization, we mentioned that randomization provides groups that are similar on observed and unobserved characteristics on average. Samples that are similar on observed characteristics are sometimes called balanced samples. However, sometimes randomization provides groups that are not actually similar simply by chance. When authors use re-randomization, They will check the comparison and intervention groups for balance on baseline characteristics. If the groups are not similar enough on those baseline characteristics, the authors will start over and randomize units into groups until they achieve their desired balance. If the study authors use a re-randomization method for group assignment, then the WWC has 2 additional requirements that must be satisfied. First, the criteria the researchers used for defining acceptable re-randomizations must be specified before assigning units to conditions. For instance, this requirement would be satisfied if a research team established an empirical threshold on a measure of group differences for acceptable randomization before assigning units to conditions. The second criterion is that study authors must provide a methodological source for the re-randomization method they used, and that source must be published in a peer-reviewed outlet. When reviewing evidence from randomized trials that used re-randomization procedures, the WWC may consult with a review team methodologist to ensure that the study authors did not inadvertently conduct a deterministic assignment process and thus introduce a confound into the study design. This might occur, for example, when conducting re-randomization with very small sample sizes or when using particularly stringent re-randomization criteria. When assessing assignment to conditions in RCTs, reviewers will need to determine whether the study used individual level or cluster level random assignment to conditions. In individual level assignment designs, individuals such as students or teachers are assigned to study conditions. In cluster level assignment studies, groups or clusters of individuals such as students or teachers are assigned to conditions as intact units, such as classrooms, schools, or districts. A defining characteristic of cluster-level RCTs is that the unit of assignment is often larger than the unit of measurement. For example, let's consider an RCT that randomly assigns teachers to the intervention and comparison groups. And let's say the study measured both student and teacher outcomes. The student outcomes measured in this study, student achievement and student behavior, will be considered as arising from cluster-level assignment, since the unit of assignment, teachers, is larger than the unit of measurement, students. And the student behavior outcomes, even if measured using classroom observations, also will be considered as arising from a cluster-level assignment design because the unit of assignment was teachers and the unit of measurement was students. In other words, the unit of assignment is larger than the unit of measurement. In contrast, if this study measured teacher outcomes, such as classroom practices, then those analyses will be considered as arising from individual level assignment because the unit of assignment matches the unit of measurement. Namely, teachers are both the unit of assignment and the unit of measurement. Importantly, when determining whether to classify an outcome as having arisen from individual level or cluster level assignment, it does not depend on the method of impact estimation or the unit of analysis in the study. Again, the defining feature of a cluster-level assignment study is that the unit of assignment is larger than the unit of measurement. Another important consideration when assessing assignment to conditions in group design studies is determining whether the integrity of random assignment has been maintained. This determination is necessary regardless of whether the study used individual level or cluster level assignment to conditions. As previously discussed, random assignment is considered compromised when an RCT does not meet the 2 criteria for well-executed randomization, namely that units are assigned entirely by chance and that each unit has a non-zero probability of being assigned to each condition. Compromised RCTs will be reviewed using the standards for quasi-experimental designs, or QEDs, which means the highest possible research rating for a compromised RCT meets WWC standards with reservations. Individual level or cluster level RCTs can be compromised in 4 ways. First, an RCT is compromised if the analyses include units not randomly assigned to conditions. However, it is important to note that cluster level RCTs sometimes include individuals in the analysis sample who were not present in the clusters at the time of random assignment. These individuals are called joiners. Inclusion of joiners in the analytic sample in a cluster-level RCT does not compromise the random assignment in a cluster-level RCT, although it can affect a findings research rating. And we will discuss the unique considerations around joiners later in this training series. A second way that random assignment can be compromised is if the analyses do not account for different assignment probabilities, as previously discussed. A third way that random assignment can be compromised is if the randomized unit's assigned condition is not the same as that unit's analyzed condition. In general, the WWC prefers estimates of program effects from an intent to treat analysis, which means that the researchers use the participant's assignment to a condition as the independent variable, regardless of whether participants actually remained in that condition. The fourth way that random assignment can be compromised is if analyses exclude units randomly assigned based on reasons with a clear link to intervention or comparison group status. Again, if random assignment is compromised, then the WWC will review the study using standards for QEDs, meaning the highest possible research rating a compromised RCT can receive meets WWC standards with reservations. Let's walk through a few examples demonstrating how the random assignment process may be compromised. Recall that an RCT is compromised when individuals or clusters in the analytic sample used to estimate findings were not subject to random assignment. Let's consider an example study where 3 students with special needs always receive the intervention because the teacher believes withholding the intervention would be unethical for these studies. If the study examining the impact of that intervention included these 3 students in the analytic sample as intervention group participants, then this would be a compromised RCT because those 3 students are included in the analytic sample, but they were not subject to random assignment to conditions. The researchers would need to exclude these students from the impact analyses in order to preserve the integrity of the random assignment process. Recall that an RCT is compromised if the units are randomly assigned to the study conditions with different assignment probabilities, but the findings are based on an analysis that does not account for those different assignment probabilities. For example, consider a cluster-level RCT that assigns schools to the intervention and comparison conditions within blocks of geographic regions. The researchers use different assignment probabilities to conditions across the regions. For instance, let's say that schools in the Northeast were assigned to the intervention at a 17:63 ratio. Those in the Midwest at a 21:79 ratio, those in the South at a 38:62 ratio, and those in the West at a 24:76 ratio. However, let's say the study researchers did not control for geographic region in their analyses. For example, perhaps the researchers only estimated a regression model for their impact analysis that included an indicator for the intervention condition, and that also controlled for a pretest measure and student age. But the impact analyses did not account for those different assignment probabilities in the design by controlling for geographic region in the analysis. The random assignment process has been compromised in this example. Recall that the third way an RCT is compromised is if the randomized unit's assigned condition is not the same as the unit's analyzed condition. For example, consider an individual level RCT that assigns students to the intervention and comparison groups. But let's say that a student who was initially assigned to the intervention condition decides that they do not want to participate, so they ultimately do not receive any intervention services. If the researchers included that student in the comparison group during impact estimation, then the RCT is considered compromised because the study authors changed the student's assigned status from intervention to comparison. In order to maintain the integrity of the random assignment process, ideally the researchers would include that student in the impact analysis as a member of the intervention group. The next chapter of this module will discuss assignment to condition in quasi-experimental designs, also referred to as QEDs. Recall that the fourth way an RCT is compromised is if the analyses exclude units randomly assigned based on reasons with a clear link to group status. Namely, random assignment is compromised when the study authors manipulate the analytic sample in a way that systematically excludes certain units based on events that occurred after the introduction of the intervention, and when there is a clear link between the study condition and the reason for the exclusion. The WWC considers a clear link to be present when the exclusion is based on a measure that may have been affected by intervention status. And as a result of this, those units excluded from the intervention condition may differ systematically from those excluded from the comparison condition, and the remaining participants in the study conditions may no longer be comparable. Let's consider an example cluster-level RCT focused on an intervention designed to improve student attendance. If the study authors exclude from the analysis any schools that had low implementation fidelity of the intervention, potentially not having implemented the intervention at all, the RCT is compromised. This is because the sample exclusion is based on schools' level of implementation fidelity, which may have been affected by intervention status. So, there is a clear link between study condition and the reason for sample exclusion, making this a compromised RCT.